Let's take this time to take a closer look at slope-intercept form of a line. Slope-intercept form of a line is called that because we have the slope and the y-intercept all in this equation. You can readily see it. If it's in this form, then you know that m is the slope and you know that b is the y-intercept. Slope-intercept form, because we have the slope and the y-intercept. Okay, let's look at why that makes sense. The first thing I'd like to point out is that a lot of times it's easier to think of this as b plus mx, because your y-intercept is always going to be your initial value. We'll get into that when we're doing word problems in a little bit, but this is because this is your starting value. And then we're going to add on the rate of change, which is your slope. It's your rate of change, however many times we need to. So as we multiply by 1, 2, 3, 4, etc., that's how many times we're going to change at this rate. So we'll start here and then we'll add or subtract based on what the rate is, however many times we need to. One thing that I really want to emphasize is that the slope is just m. It is not mx. If I say that y equals 3x minus 1, the slope is 3, not 3x. Do not say 3x. It is just 3. The slope is m, not mx. Another important thing is that the y-intercept includes its sign. Do not forget about the sign of the y-intercept. Here, the slope is 3 and the y-intercept is -1. B is -1. In this case here, the slope is 4, not 4x. In this case, it's +2 is B, is your y-intercept. In this case, your slope is 5, not 5x. It's just 5. And remember that this y-intercept is -6. So, m is the slope, not mx, and the y-intercept includes the sign with it. A quick and easy example I like to use is the taxi. It charges you $2 to get in and it's 50 cents a mile after that. So you would start with $2 and then you would add 50 cents for every mile. So there you go. mx plus b. Your cost is going to be what you start with and then however much you're changing per however much changes. So it's 50 cents for every mile as you go 1, 2, 3, 4, etc. miles. You're just multiplying to see how many times you have to add this. That's what's going on with slope-intercept form. So how do I know that b is always going to be my y-intercept? Well, let's look at a graph to check that out. One way, I can just scroll this and you can see that clearly b ends up being my y-intercept each time. There it is, 0. There it is, 2. What I mean by y-intercept is where does it intersect the y-axis. Here's the y-axis, the up and down one, y to the sky. And as I move around, this is where my line crosses. -2, +1.6, etc. Well, why does this work mathematically? Well, that's because just in the last lesson, we learned that the y-axis is a vertical line, which means it has to be x equals something, right? Well, what does x equal on the y-axis? It equals 0. There it is. This is where x equals 0. It's the y-axis. Just in the same way that the x-axis is where y equals 0, right? Here's y equals 0, and here's x equals 0. We'll get rid of this guy because we don't care about him. Here's x equals 0, and that's the y-axis. So everywhere I'm crossing on the y-axis, x has to be 0. Let's look at what that means for when y equals mx plus b. So if y equals mx plus b, and I know that x equals 0, what does that give me? Y equals m, your slope, times x, which is 0, plus b. What is any number times 0? It's just 0. So this is y equals 0 plus b. And so y has to equal b. Y always equals b when x is 0. And I know x is 0 at the y-axis. So if I'm looking for the y-axis, I know x is 0. And I know that if x is 0, then y has to equal b. And there you go. The y-intercept is always b. So I hope slope-intercept makes a little more sense to you. We're going to start using it, and by the end of the week, we should feel pretty good about it. We'll be using this for the rest of the quarter.